Okay, so in this video, we're going to be looking at part of the course section of the 2018 NHT Further Maths Exam 1. So that part we're going to be looking at is data analysis. And so let's look at the first question. The stem plot below shows distribution of beak length in millimeters of example sample of 33 female birds of the same species. So we've got our key, so that's important to remember what the key shows, and we've got our number, which is n equals 33. So the first question is, for these 33 birds, the median beak length is, and we've got to work that out, okay? And to me, the easiest way to do that is, you can apply the n plus 1 rule for, so n plus 1 over 2. And what this is telling you is the position at where the median is going to be. So our n is 33, so it's 34 divided by 2, and that's 17. So we're after position 17. So in this case, I'm literally going to count out and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So that's where my median is. In that case, the answer is C. All right, so I would personally do it like that because that's probably the easiest way. So percentage of these 33 birds with a beak length of less than 25.4 millimeters is closest to. So in this case, you want to look at, we're after that, what's that percentage of the total. Now I'd actually count these ones and say I've got, when I say these ones, I mean these, means I've got 7 above that. So that means in this section here, I have 33 minus 7, so I'm going to have 26 numbers. So basically in this part here, it's going to be 26 over 33 times 100. And when you do that, what you'll get is 78.8%. So 78.8%. Okay, so that's how you could do questions 1 and 2. All right, the histogram below shows the distribution of beak length in millimeters of a sample of 800 birds of the same species. We've got female and male in there. So the beak length of this sample of 108 birds is most frequently. So the most frequently, so we're looking for the highest amount. So that's going to be in this block here. All right. The part that says greater than or equal, that means in terms of this histogram here, it's that and going to just before we get to that point. So it's not including the 24.5, but it's including the 24. All right, so what does that mean? That means I look down and say, and greater or equal to 24. So it means this, because that's what I said at the 24, and less than 24.5. It's not including the 24.5, but it's just less than. So in that case, we're going to look for D. Okay, so let's clean some of that off. The interquartile range for beak length for this sample of 800 birds is closest to. So remember, interquartile range, the best way I look at it is to think N, because remember, interquartile range is Q3 minus Q1. So we've got to work out what our Q1 and our Q3 are in this particular question. So how would I do that? Well, the way I would look at this is to go n equals 108, and then I would split that and say I've got basically 54 and 54. And the reason I'm doing that is so I want to know those are my halves, and in that, so I'm looking for basically the two positions. So it'd be 27 and 28. And it's basically going to be the same for that, and that's effective that position there as well. That's the position I'm after. So I'm after that position in between those two numbers. So that means when I go up here, I'm going to look and go, all right, there's 2 and there's 11. So I've got 13. So I'm going to go 2, 13, 13 plus 14. 13 plus 14 is 27. So it's basically going to be 23. And so when I say 23 on this one, what I'm meaning is it's on here. It's on this line here. And so when I go the other way, so that's my Q1. I'm going to go, how was that? That's 1, and then I've got 4, and then I've got, that's going to be 10 because it's 6 there, 10, and that's 17 there, so that's going to be my 27. So I'm looking at this line here. So I'm basically, that's my Q3. Okay, so in this question, the answer I would give is my range is 24.5 minus 23 would be 1.5. So I would select B. But just keep in mind that when the examiners looked at this, they said the best estimate for the IQR was 1.5. But they also said under particular conditions, it would be possible for the IQR to be as small as 1 or as large as 2. Therefore, options A and C were also accepted in this particular exam. But the way I've done this, I would be picking B pretty much like what their preferred option was there. Okay, so let's look on to the next question. So question 5. So okay, so in this question, so question 5, the variable's height, so it's got that sort of format. Enthusiasm for playing football, so it's got an order. They've both got an order. They're both categorical, but they've got an order. So one's going from less than to higher than sort of thing, and one's going from, so it's got an order. So they're both going to be ordinal variables. The parallel box plots below display a distribution of height for 3 groups of athletes: rowers, netballers, and basketballers. And this is one where you've got to say which of the statements is not true. So let's actually have a look at this. And we look at A, the shortest athlete is a netballer. That would be the case. So that's actually true. So we're not going to include that one. Oops. How did I manage to do that? I don't know. The rowers have the least variable height. And we can see when we look at this, that that's also not also true. So it can't be right for this question. They have the least variance in their data. C, more than 25% of the netballers are shorter than rowers. And when we look at that, essentially, we go down there. That should be a nice straight line. That's 25%. Remember, in a box plot, that's 25% of your data, and 25% of the netballs are shorter than all rowers. So it can't be that one either. The basketballers are the tallest athletes in terms of median height. We're looking at the median there, and we can see that none of the other ones match that median. So again, that one's wrong. Oh, so that one's right, but therefore not the right answer for this question. And E, more than 50% of the basketballers are taller than any taller than any of the rowers or netballers. If we were talking about netballers, it would be correct, but as I sort of showed there, some of the rowers are actually are past that where the median is for the basketballers. So this one is not true, so therefore it's the correct answer. Okay. So this is going to be used for questions 7 to 10. It's got a bunch of things for 12 athletes for lean body mass, percentage body fat, and body mass index. Okay. So this is one you're ideally probably going to have to put in your calculator. Okay. So I'm going to bring a calculator up in a moment for this. Okay. So in this one, we're just looking at lean body mass. All right. So just looking at lean body mass. So I've got my data here. I've put it all in the calculator. I've prepared something earlier, so just to save time. And so what basically we're looking for our mean. So our mean is 55.68. So 50 in this case, if you look down here and go down here, you can go 55. Down this one, 55 point. What was it? 68, so 55.7. That means, if we look at that, that these three are out. Then we look at our standard deviation. Remember, that's in heat, that's SX. So that's 4.7, so 4.8. So that means our answer is E. All right, so this one here, where least squared line is fitting data using percentage body fat as a response. So that's your Y, and the body mass index as your explanatory, that's your X. So this one, for starters, you can cut some of these out just by the fact of what should be there. So PBF needs to be in this part here. So if it's not, like B and D, they're out. So if you haven't got your calculator's not working for some reason, you've cut it down by 40%. All right, so you've got a 6% chance to get it. Well, maybe that's not the right way. Ignore that last part. But I would actually put this in a calculator because it's going to be harder to work out. So as I did before, look what I prepared earlier. So that's this one here. So I've got BMI on my X and PBF on my Y, and we can see that we get minus 4.7 plus 1.15x. So that's 1.2. So therefore, our answer is going to be A. Okay. The hardest part in doing some of these questions is the time it takes to put the data in, but once you've got that, it's not that hard to do. And now, again, we've got a Pearson's correlation coefficient between lean body mass. So that's our X. And PBF, percentage body fat, which is our Y. And as you can probably guess, I prepared something earlier. And you put that in your calculator. If you can't remember how to do it, it's menu, stats, stat calc, and you want to go linear regression. Okay, so let's get back out of that because we just want the. So we're going to go negative 1.24. So remember, we just want R. Negative 0.124 is B. There's our answer. All right, question 10. So in this case, we're going to make use of this. So remember, when we do residual, what we have, so residual, to calculate it, equals Y of the actual minus Y of the predicted. Predicted comes about from there. All right. So we want a BMI of 22. So that's where this is 22. So let's actually go for the actual Y actual, just so we're, so we've got that. So we're going to look at Y actual. So that's a BMI of 22. So let's go back up to here. And BMI of 22. If we read that there, that's a BMI of 22. And that's going to give us, and just to make sure, LBM of 48.3. All right. So that means we've got this one here, 48.3. And now we just got to do Y predicted. So let's actually calculate that now. So lean body mass predicted equals 48.9, because that's what the equation says, plus 0.32 times 22, and that will equal 55.9. Okay, so I'm going to go 55.9, and that means when I put that in my calculator, I'm going to get minus 7.6. So the answer would be A. Okay, next one here. So we're looking at this. This is for the next two questions. So I've got this data. There's a no trend, irregular fluctuations. We know there is a trend. Okay, so we can get rid of that one. The fluctuations aren't irregular, so we can get rid of that one. There's an increasing trend, yes, so that could be C or E, but it's not. It's probably not to do with seasonality only, so it's not going to be that one. So it's increasing trend, but it's not just seasonality. Okay, so we're going to get rid of that one. D, it's also not just irregular fluctuations, it's actually both. So we're going to go for E. So keep in mind the irregular part here, there are a function of all time series plots. Okay, all right, so that's question 11. So question 12, the dot above 1957 corresponds to the number of passengers in January 1957. So 5 median smooth number of passengers for August 1957. Okay, so that means on this one you almost have to go. So the reason I want to zoom in a little bit is because this is going to be hard to put it in. So what you need to look at this one is, and the reason I was saying before, like the zoom in, so I can actually draw it here better, so it actually makes sense. What I'd put here is, this is I do it graphically. I'd go January, February, March, April, May, June, July, August, September, October, November, December, because that would be now 1958. So we can just ignore that one. So what we're actually interested in here is this point here. How's that going to be smooth? Okay, and the way we can do that is we look at, we've looked at these points here, including the August one. There are 5 points. It's a 5 median smooth. So we've already done the x-axis. So now we need to do the y. So we're going to count this and go, we count up going up in order. So we go 1, 2, 3, 4, 5. So I need to get this one here where it would match up to August. Okay, and that would be this spot here. And if we look at that in terms of passengers, that's basically coming right across there. All right, so now we come back here. So of the data we've got, the closest to, if you look at that, it's between 4 and 450. It's probably close. It's between 430 and 445 and 440. So we're going to have B. So it's going to be 435. Okay. So that's how you can do a question like that. Question 13. All right. Is the least squares line is used to model the trend in time series displaying winning time in seconds for the men's 1500 meter race at each Olympic Games held during that period. The explanatory variable is year, and that's our equation. So the coefficient of determination is 0.8689. Now, to convert that to R becomes, because remember that's R squared, and you're going to square root 0.8689, and that would give you an answer of 0.9321. Now, this one you just got to be really careful because that's R. That's just the square root of that number. So you might pick E, and you would be wrong. And why would you be wrong? Because you need to look at what the gradient is. In this case, the gradient, because remember when you square root something, it's basically saying plus or minus, and that's what your answer is going to be. And you need to work out which one's the case. Because your gradient is negative, your answer is going to be A, not E. Okay? All right, question 14. Now this is one where you've got to be careful which parts you do with it. All right, and I'll show that why. Because remember, if I add up all these seasonal index here, because I've got 4 quarters, my total's got to equal to 4. Now, if I do that, that means this here is equal to 0.64. You go, haha, I've got my answer in circle A. Guess what? You're wrong. Because what you need to do is you've got your seasonal index equal to, in this case, your actual value over the deserialized value, and you're being told the deserialized sales were 2.545 million. So that's going to be, if I rearrange this to equal, and I want the actual sale, so I need A equals ID, that means I 0.64 times 2.45, that's going to equal 1.57. So your answer would be B. Okay, this one is a little bit more annoying purely because of the timing involved of it. So the 6 mean smooth number of surfboards with centering repaired for June 2007 is closest to. Now you could probably do this in your calculator. If you've got the right sort of formula put into that, to do that, you could do it. But I'm going to quickly show, well, I'm going to show you a way you can do it sort of manually, and it will give you the right answer. So this is something I've prepared earlier, surprisingly. And it's something I just put together in Excel. And the idea is it gives you a sheet where you can just put the information you need. And so what I've done is this part here. This is the answer I want. I want, because it said, if you remember correctly, June 2017. Okay. This is the centered, where the centered data for June 2017 is. To get that, I need to generate this value and this value. Okay, so I've given them some colors, so I'm going to get rid of the highlights there for a sec, just because I want to make it really clear. Now, to get this color here, I need to get the mean of those colors, and to get this value here, I need to get the mean of those numbers. So I'm surprised. I assume you're probably going to say to me, or I know what I'm going to say is, look what I prepared earlier. So the red would be this value up here, and that will give you 69.7, and then you'll do the black, and that will give you 61.7. Then you add those two together and divide by 2, because so basically, so 69.7, 61.7, so 69.7, 61.7, I'm going to add them up, divide all that by 2, and that will give me 65.7. So 65.7. So when I come over to here, my close, so 65.7, and is closest to 66, which would be D. Okay, and that's how I'd use a graph thing like that. I'd probably put that in my summary book, so you've got it for both exams. Okay. So what we want to look in this one, it's got, if the data in the table above is used to estimate the seasonal indices for the number of surfboards repaired each month, the seasonal index for May would be closest to which of these values? So what you want to look for here is you want to get the average of these numbers. So what you're going to do is you're going to add all those up and divide by 12, because there's 12 numbers. And what you'll get is an average equal to 92.75. Okay. And I mean, you can look at this and immediately say that for May is 54. All right. So if May's 54, you know it's not going to be these two, because remember, it's going to be the seasonal indice is equal to the value for that month. So the value, I'm saying for this month because that's what we're talking about, for month over the average for all the months. So in this case, it's going to be 50, what did I say, 54 divided by 90, oops, I should write that again because my 54 is pretty bad, 92.75, sorry about that phone call, my apologies on that. And that would equal to 0.58. So that would be C. Okay, and so that would be your answer for that one, and that is the data analysis section of the core part. Okay, thanks.